Hello, in this lecture we will find the values of x and y. In the drawing we have a shape, and the area of this white shape is equals to 240 units squared, and the width of the shape is 15 units and the length of the shape is 20 units, and we want to find out the size of x and y. Okay, first of all we will name the vertices of this white shape. We will name this vertex as A, and we will also name this vertex of the white shape as L. We will name this vertex as C, and we will name this vertex as D. Okay, so we actually gave names to the vertices of the white shape. In the next step we will lengthen segment X to a size of 20 units. So we actually lengthen segment X, we lengthen segment X to a size of 20 units, and then we will lower perpendicular from this line to segment CD of the white shape. Okay, we lowered perpendicular from this line to line segment CD. So actually this angle equals to 90 degrees. Angle CD, we will call this vertex F. So actually angle CDF equals to 90 degrees, and also angle DFL will be equal to 90 degrees. So actually from the shape that was given to us we created rectangle. The shape AFCD is a rectangle because of the fact that the size of segment AF equals to the size of CD, that is 20 units, and also AF is parallel to CD, and also line segment AC equals to line segment AF. Line segment AC equals to line segment FD, both of them equals to 15 units, and also FD is parallel to AC. So actually AFCD is a rectangle. Okay, AFCD is a rectangle. Shape AFCD is a rectangle. and the area of any rectangle equals to the length of the rectangle times the width of the rectangle. So the area of any rectangle equals to the length of the rectangle times the width of the rectangle. Again, the formula for the area of any rectangle equals to the length of the rectangle times the width of the rectangle. And in our specific case, the area of rectangle AFCD will be equal to the length of the rectangle, that is 20 units, times the width of the rectangle, that equals to 15 units. So 20 times 15 is 300. So the area of rectangle AFCD equals to 300 squared units. Okay, so the area of rectangle AFCD equals to 300 squared units. The area of rectangle AFCD equals to 300 square units. Okay, and actually the area of the right triangle LFD of the right green triangle LFD will be equal to the area of the rectangle minus the area of the white shape. Okay, the area of the right green triangle LFD will be equal to the area of the rectangle minus the area of the white shape. Okay, very simple. You can see it from the drawing. The area of the rectangle minus the area of the white shape equals to the area of the right green triangle. Okay, so we can write it down that the area of right triangle LFD equals to the area of the rectangle minus the area of the white shape. Again, the area of the right green triangle LFD equals to the area of the rectangle minus the area of the white shape. So the area of the rectangle is 300 units square and the area of the white shape is 240 units squared. So the area of the right green triangle LFD will be equal to the area of the rectangle that is 300 units squared minus the area of the white shape that is 240 units squared, or the area of the right green triangle equals to 60 units squared. Okay, the area of the right green triangle equals to 60 units squared. Again, the area of the green right triangle equals to the area of the square minus the area of the white shape. That is to say, the area of the rectangle equals to 300 units square minus the area of the white shape that it is 240 units square. So the area of the right green triangle equals to 60 units squared. Okay, so I will draw again the right triangle LFD. Actually, the size of LF, that is side in the triangle, in the right triangle LFD, will be equal to 20 units minus x. Again, 20 units minus x is the size of LF. Okay? So actually this is the right triangle LFD. The size of FD is 15 units and the size of FD is 20 units minus x. Okay, the size of FD is 20 units minus x and the size of the hypotenuse is y. But we have already know that the area of the right green triangle equals to 60 units squared. So we can write here that the area of this right triangle equals to 60 units squared. Okay, the area of this right triangle equals to 60 units squared. So we can use the formula for the area of any triangle in order to find out the value of x. And the area of any triangle equals to the base of the triangle times the height to the base over 2. So the formula for the area of any triangle in the world equals to the base of the triangle times the height to the base over 2. And you should remember that the height must create 90 units with the base. The height must be perpendicular to the base. Okay, so according to this formula we can calculate the area of this right triangle. We have already know that the area is 60 units squared, but when we use the formula we will find the value of x. So our first equation will be the area of the right triangle LFD. The area, we have already know that the area equals to 60 units, so we can write here that the area of the right hand triangle is 60 units, and it equals to the base of the triangle, that is actually 20 minus x, times the height to the base, that is 15. Actually, the height, that is 15, creates 90 units with the base. So FD is the height of this right triangle, so the base is 20 minus x times the height to the base is 15 over 2. Okay, so the area of the right triangle, that is 60 units square, equals to the base of the triangle, that is 20 minus x times the height to the base, that is 15 units, over 2. Okay, again the area of the right triangle LFD equals to the base of the triangle, that is 20 minus x times the height to the base, that is 15 units, over 2. Now we will multiply equation number 1 by 2. We'll get that 120 equals to 20 minus x times 15. Okay, we multiplied equation number 1 by 2. 2 times 60 is 120, and here we got that 20 minus x times 15 over divided by 2 times 2 is 20 minus x times 15. Now we will open the brackets in the first equation. So we open the brackets in this equation. 20 times 15 is 300, and x times 15 is 15x. Now we'll subtract 120 from this equation. So we subtracted 120 from this first equation. 120 minus 120 equals to 0, and 300 minus 120 equals to 180. So in total we got that 0 equals to 180 minus 15x. Now we will add to this equation 15x. So we added 15x to this equation. 0 plus 15x equals to 15x. So we got that 15x equals to 180. We will divide equation number 1 by 15. So we got that x equals to 12 units. Okay, the value of x is 12 units. And actually now we know that 20 minus x is 20 minus 12, so 20 minus 12 equals to 8 units. So we have a right triangle. We know that one side equals to 8 units, the other side is 15 units. We can use the Pythagorean theorem in order to find out the value of y. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, y square, the square of the hypotenuse is y square, equals to the sum of the squares of the perpendiculars, equals to 15 square plus 8 square. Okay, according to the Pythagorean theorem, the square of the hypotenuse is y square equals to 15 square plus 8 square. 15 square is 225 and 8 square is 64, so I will write it down. So we got that y square equals to 225 and plus 64. 225 plus 64 equals to 289, so I write it down. So we got that y square equals to 289. In the next step, we will take a root out of equation number 2. We get that y equals to 17 units. Okay, so we got that y equals to 17 units. And we have already found that x equals to 12 units. So the answer to the question is that x equals to 12 units and y equals to 17 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the values of x and y in this white shape. We know that the area of this white shape equals to 240 square units, and the width of this white shape equals to 15 units, and the length of this white shape equals to 20 units, and we want to find out the value of x and y. Okay, actually we lengthen segment x to a size of 20 units, like CD, that is also 20 units, and then we lowered perpendicular from point F to segment CD. Okay, so angle CDF equals to 90 units and angle LFD equals to 90 units. So actually, from the shape that given us the white shape, we created a rectangle, because actually AF is perpendicular to CD and AF also equals to CD, and FD is perpendicular to AC and also FD equals to CD, and also FD equals to AC. So actually we created a rectangle from the area, from the shape that was given to us, and we know that the area of any shape equals to the length of the shape times the width of the shape. So the area of the rectangle that we created will be equal to the length, which is 20 units, times the width, that is 15 units. So the area of the rectangle that we created will be equal to 300 square units. Okay, but the area of the green right triangle will be equal to the area of the rectangle minus the area of the white shape. So it will be equal to 300 units minus 240 units squared. Or the area of the green right triangle will be equal to 60 units. Okay? So actually I draw the right triangle LFD again, and we know that the area of this right triangle LFD equals to 60 units squared, this side equals to 15 units, and this side equals to 20 minus x. So we use the formula for the area of a triangle in order to find out the value of x. And according to the formula of a triangle, the area of a triangle equals to the base of the triangle times the height to the base over 2. We should remember that the height to the base must create 90 units with the base. So the area of this right triangle equals to the base of the triangle, that is 20 minus x, times the height to the base, that is 15 units. Actually FD is the height to the base because it creates 90 units with the base. For that reason FD is the height to the base. So actually the area of the right triangle LFD is the base of the triangle, that is 20 minus x, times the height to the base, that is 15 units, over 2. And we know that the area of this right triangle equals to 60 units. Okay? So we got that 60 units equals to 20 minus x times 15 over 2. Now we multiply the equation number 1 by 2. We got that 60 times 2 is 120. And here we have 20 minus x times 15. We open the brackets in equation number 1. We got that 120 equals to 20 times 15 is 300, and x times 15 is minus 15x. Okay, so we solve this equation and we get x. We get the value of x. Actually, the value of x is 12 units. We got that the value of x is 12 units, and now that we know that x equals to 12 units, we know also that this side of the right triangle equals to 20 minus x, and x equals to 12. So this side of the right triangle equals to 8 units, this side equals to 15 units, and we can use the Pythagorean theorem in order to find out the value of y. According to the Pythagorean theorem, the square of the hypotenuse, that is to say y squared, equals to the sum of the squares of the perpendiculars, equals to 15 squared plus 8 squared. Okay? So we wrote our second equation that states that the square of the hypotenuse is y square equals to the sum of the squares of the perpendiculars equal to 15 square times plus 8 square. Okay, so we solved the second equation and we found out that the value of y is 17 units, and we have already found out that the value of x is 12 units. So the answer to the question is that in this y shape the value of x is 12 units and the value of y is 17 units. Okay, thank you very much.